אז אמרתי שזה קיבלתי פרס ישראל, כי אני יודע לעשות
Thank you, everybody. Nice to see everybody here. Good afternoon. It is a really great pleasure to introduce Abital Gazit. It's a tremendous pleasure, actually. Always when you introduce people, I usually have to tell a lot about the background so the audience will understand that they are important people. Here, I just have to say, look, he got the Israel prize. You know, it says it all. But still, I promise Abital that I will not say much, but I don't want to take too much of his time. But just a few things. Abital did his PhD at the University of Wisconsin, finished in 1974. And then he did his postdoc there. I started actually here in Tel Aviv, and then returned to Tel Aviv to the Institute of Nature Conservation. And since then, he's a faculty member in Tel Aviv, and he did a lot of things during the years. I could list a lot, you know, when I read, I did my homework, so I took all the arguments and all the list that, you know, people wrote about what he did in his life. I'm not going to just read it all, but another way to say that there's actually almost no body of fresh water in Israel that we go and visit, that Abital was not somehow involved in either studying this or monitoring it or conserving or do some rehabilitation work with this. And if it is not this creek, it will be the creek nearby. He really was the pioneer of freshwater ecology and immunology in Israel, and many of the people who work in the field these days are former students. And among many things that I should mention, maybe at some point he was really the head of the School of Zoology. Back then it was the Department of Zoology. He was also one of the founders of the Israel Society for Ecology and Environmental Sciences, what we call the Amutah Ecologia and הסביבה, and he was one of the head of this society. And after he retired for the past decades, he was the head of the teaching program, the program for environmental studies in the Porter School of Environmental Studies. And he's all the time still active in conservation and was involved in many committees and organizations. Almost all of them somehow is connected with Abital work. And without further delays, I will just congratulate you again and let you write a speech. Let's see if we can. Everything just before you start. Thank you very much.
שומעים?
בסדר.
שומעים עכשיו? כן. Okay. I'm really excited. Thank you very much, all of you, for coming. do. The issue is lack opportunity in academic career. I hope I will prove it to you. Now, I will start with a disclaimer. You all know that I don't wake up in the morning and start to speak English. So bear with me. Another one is that I just passed the age of 80. So I keep forgetting things, including words. And the last thing is there are some audience abroad, and I tell them, for you, I can speak and be rusty if it's okay. They will get the recording because it's in the middle of the night in California, in New York. So bear with me and we will start. Okay, I showed this picture for what is written. The difference between the sciences and arts is that the people who have been awarded the prize of Israel in the arts are responsible on their own. They did almost everything by themselves and they deserve it. However, in the sciences, we are a team. Nothing is done on your own. You may be reading, you get advice from your students, and we all share this prize. If you decline it or not, it's yours. Now, the achievement that the committee recognized is summarized by the extending the foundation of research and teaching of freshwater ecology at the academia in Israel. Before, it wasn't existing. And then there are three groups of work bodies that I work mainly. It's the ecology, pollution, and rehabilitation of Med rivers. It's Mediterranean climate rivers. We nicknamed them Med rivers. Uncovering the role of the littoral zone, the shallow water environment. I'm explaining to those who are not biologists and not aquatic ecologists. So bear with me. Uncovering the role of the shallow water environment in Lake Kinneret. You'll be surprised how little you know. Oh, sorry. And the last one, the ecology of temporary ponds or rain pools. Actually, without meaning to be there, I worked on this for 40 years, and finally there was a revolution from the verge of extinction that Mendelssohn members. It's now a branch that every head of municipality wants to have it in his jurisdiction. Okay, now we start my academic career at 68. I was a master's student at the zoology department at that time, and then in between was the Six-Day War in 1967. We lost a year, so I started in 1996, and before then 3 years of biology. So just to complete the background. And now it will be 53 years. Now, lack opportunity in academic career. I start with lack, but it's related to tragedy, saying all the others are good luck. I was a short step from not being with you, and it's in the academic, not an accident on the road. And it was a miracle. More than I'm going to tell you, a miracle that really happened to me personally and to others that were involved. Now, I'm happy to see your faces that were with me at this occasion. That time, biologists here, at that time in the 70s, we had a wonderful field trips for a week. We went to a certain region of the country with all the stuff, zoologists, botanists, Itzhaki, the geologist, and others. And we really studied biology in nature, not in class. Now, on the last day, it was wonderful. On the last day, I was leading 2 trucks. They were similar to this one, but without a solid roof, but covering. I was leading with a jeep that the zoology department had a jeep of its own. And late Professor Gerling came to me and said, the last station is Sde Boker. I want to go there to prepare the area. And of course, I moved to where he said by the driver, and he took off to Sde Boker. I quickly fell asleep, and I wake up. I think it was in the here in the circle in this curve that I see the driver trying to shift gear to low gear, and he's unable. And it's downhill, and the truck fell, actually turned over 30 meters down. I fell 3 meters and the door opened and the truck jumped over me. This is the personal miracle. And continued to roll over until it ended up in the wadi 30 meters. Unfortunately, 2 students died. And I'm surprised. I think in our zoology department, we should have something to memorize these students. I had to go to the לשכה משפטית,
Legal counsel.
okay, legal counsel to get information of their name. I told them I was there. But we had a miracle that I will tell you about that saved the life of other students. 30 were wounded, some of them really severely. What happened at that time, fighter jets, Mirage, those of you remember, were training on attacking trucks in the south of the country, on the road. They were going down on us, I remember that. And one of them saw the accident. He immediately called the army camp, called, and at that time, a medical unit was training there. So it didn't take long for them to come and give first aid to the injured student. I had a severe cut on the back of my head and I was unconscious. So I was taken with the helicopter to the center of the country, and I was unconscious for a week. It had other effect on me, but I don't have the time to, and it affected my academic career, but I don't have time to tell you that. Okay, that's the bad one. Let's begin now with the good one. In 1968, opportunity, I call it lucky me. I was about to graduate, and my thesis was in freshwater ecosystem, title distribution, biology, and ecology of caddisflies of Israel. Phycoptera, to those of you who know, it's a group that the adults look like moths and the larvae develop in water. And almost nothing was known, and I took it upon me with Professor Kugler. And at that time, 68, Professor Wilhelm Rode from Uppsala, Sweden, one of the leading limnologists. Limnology is the study of lakes, rivers. Limne is marsh, lake. He was also the head of the International Society of Limnology. He was an expert on algae, and he came to help us to erect the Kinneret Limnological Laboratory. And I don't know how I took the courage, and I called him and I asked him if he would like, if he will meet me. And he accepted and agreed. We sat and talked, and then I told him, I'm willing to be your personal helper. Sancho Pancha. And he loved it and said, okay. So I stayed for 3 months. This was my first stop. This is an opportunity. You need to know how to use it. Now, I was looking for a PhD position. And as you all know, we send letters almost everywhere, 20 letters, I say, to Europe and to the US. But the place I wanted to be was Madison, Wisconsin, and you will know in a minute why. The late Professor Arthur Hessler, one of the leading immunologists in the US, first came to Madison, Wisconsin in 1937, and at that time, the Laboratory of Limnology, now it's the Center of Limnology, it was known that the birthplace of lake research in the US. Now, Art was one of the leading figures in the 20th century of the ecologists, and one of the most important findings of his is that he discovered how the salmon find their home water, the river that they were born. And he came with the idea of olfactory imprinting. He had a wonderful story how we got there, but I don't have time to tell you. Art, as we nicknamed him, was president of the American Society of Limnology. There was oceanography, and it was American Society, the president of the American Society of Zoologists and the Ecological Society of America. So you see, it's a really leading ecologist in the US. And he was elected to the American Academy of Art and Sciences in 1972. Here comes the most important sentence for me. A letter of recommendation that I attached to the letter that I approached Professor Hessler from Rode paved my way. Later on, he said to me that if Rode recommends, I don't need anything, I accept. And just that you know, he advised 52 doctoral students, and I was lucky to be one of them. Okay, and here on start my most satisfying journey in limnology. Okay, what he also told me, if you want to be a limnologist, you have to wet your feet. And he sent me to northern Wisconsin to a pristine lake that you can actually bend down and drink the water. It's what we call end moraine, where the glacier stopped and melted and the water is clear. And then he told me, you are there alone on your own. Okay? And this is the result. I got a boat, a lumocraft, and I got all the equipment. I got nets. Here's the net, and I got dredge to take bottom samples, and I have a bottle to take samples from different depths. And I have to operate it all by my own. So all the woody stuff that you see are accessories that I put on the boat so I can release the equipment and take the samples. And I was there on my own. No, it's not moving. I don't know what the problem is. I'll go back. Maybe battery. Ah, okay. Works. Thank you very much. Thank you very much. So I was on my own, but not really. Immediately you will see my assistant. This is my sweetheart, Mika, my daughter, who was with me on the boat at the time. And you can see that we were self-sufficient in terms of fish. If you're hungry, you want fish, you go to the lake, you get different kinds, pike, and largemouth bass, and other fish that were there. Okay, so this, of course, will be one of my unforgotten experiences in life. Now, I needed also to do analysis. It's not just taking sample of organism and try to see who is there. I need to measure oxygen, pH, and all the others. And I needed a lab nearby the cabin, which was, by the way, well equipped. This is one of the well-to-do Americans. They had some cabins around the lake on one side only. The other side was a forest, as you can see at the back of my boat there. And I found a privy or outhouse, Bet-Shimush Sadeh, שהיה שם, and I turned out to transform it to a lab, as you see here, and I did all the experiment. At that time, to measure oxygen, it's not just putting a sensor in the water and getting immediate reading. You have to do titration, which is named after Winkler titration, and did 100 of them. By the way, until today, this is the most accurate measurement of oxygen, and they calibrate the sensor using Winkler titration. You can see the lower value because it's 52, 53 years. The cabin 20 meters from the lake, just under believable situation. Okay, now we start to talk about the ecology and the research, ecology, pollution, rehabilitation of Mediterranean type rivers, and flood is a central issue. Okay, those of you who may not know, we have 5 regions in the world that are Mediterranean, that have Mediterranean climate. Ours is the largest, and this is why it got the name Mediterranean climate. They are all widely separated, as you can see, but they have very similar in their ecology and biology. Okay, by the way, I spelled Mediterranean with small m because the capital M is for the Mediterranean basin, and Mediterranean type or Mediterranean climate is with small m. Okay, so what I did with my colleague that will be shown in a minute is we came up with a unifying concept of Mediterranean climate streams or med rivers. The two major issues is contrasting seasonal hydrology that you all know. We have winter with relatively surplus of water, we have summer with less water, and flood as the yearly reset mechanism. And this is where I have conflict with engineers. They want to eliminate the flood, and I say, by no means, if you eliminate the flood, there is no stream. And I went for, took sabbatical at Berkeley, California, and fortunately for me, really, I met Vince Resch. Professor Vince Resch is one of the leading aquatic biologists in the US, not only in California, a wonderful guy. And we wanted to, what we plan to do is, how do we restore streams in California and Israel? And then we realized we don't know much about the attributes of these streams. So we worked out and came up with the concept, and we came up with a paper, Stream in Mediterranean Climate Region, Abiotic Influences and Biotic Responses to Predictable Seasonal Events. Predictable is that you know there will be winter, you know there will be summer, you don't know how the winter will look or how the summer will look. Anyway, it became a key paper. I think at the moment there are more than 1,300 citations. There is a follow-up that was in 2013. What did we learn since Gazit and Resch's paper? And here you see a typical hydrograph. We call this hydrograph of the change. In black, you see the floods. In this case, it's an intermittent stream. In summer, so we have flooding and we have drying, flooding and drying. And I want to turn your attention to the most important period here is spring and early summer. This is the window of opportunity for the biology, for the biota. There is enough water, temperature is increasing, and this is where they celebrate, they reproduce. And you can see it now in this, this is Hashofet stream that probably reminds you of my student, now Dr. Yaron Hershkovitz. You see this is the dry bed, and what the drying is doing is disrupt connectivity. It contracts the habitat, it becomes smaller. Eliminates lotic habitat. Lotic is flowing habitats. Enables encroachment of the vegetation. There's nothing to wash them out, so they close the bed. Increase sediment accrual, sediment accumulation, and increase salinity and nutrients because there is less water and the water evaporates and the concentrations of the elements in the water increase. And the increased fluctuation of the water quality conditions because less water, the air temperature can affect, for instance, temperature. Now, what is the flood doing? Just the opposite. Restore channel connectivity, modifies channel morphology, restructure and expand habitats, homogenizes water quality conditions, redistribute materials, resources, as well as biota. And the most important, I already mentioned it, the Med River, the floods act as the reset mechanism. The stream is reborn every year in winter with the first flood. Okay, now you will see the hydrology typical to a Mediterranean climate stream. And we see here the altered hydrograph in yellow and the original or historic hydrograph. And you can pay attention here that the window of opportunity is missing in the yellow. So if this is the stream, we lost the community that was there. This is the insight that came about from the work we did together. And in order to rehabilitate the stream, you need to restore the hydrology, and you don't do it by giving, this is what was done in this country. We have water to allocate to the stream, we give it a certain amount the year round. No, you allocate it by a table. Restore in dashed yellow the hydrograph original in quantity, but it's original in shape, and the window of opportunity is restored. And now the other aspect And you see a one in the right corner there. This was fire in Sano, and all the detergent ended up in the Yukon River. This is one of our major problems, that streams are the end, receiving end of all this force. Anyway, what we are doing is we are using aquatic insect or macroinvertebrates. It's not only insect, it's worms and snails and everything that is in this category. And what we do is we compare what is there in the unimpaired stream, meaning it's not being disturbed, to what we suspect is a disturbed stream. If there is a similarity, everything is okay. If there is dissimilarity, and especially there are dominant species, as you know, in the ecology and the ecosystem, if one species is dominant, something is wrong, then we can tell what is the stream health. Okay, moving to Lake Kinneret, uncovering the role of the littoral zone. And here I was lucky again. At the end of my PhD, a new program came to Europe and the US, International Biological Program. This was the first time that scientists and ecologists started to work in teams and working on ecosystems. It wasn't before. And I was lucky to be there. And Wisconsin was one of the sites, and 50 scientists from Wisconsin were working. And I was working with my colleagues on one of the lakes there. And we worked on the littoral zone. So this was my first exposure to the littoral zone in this lake. And here you see the students, and starting in the littoral zone, little was known. And what became is with the idea underscoring a neglected insight, the littoral zone provide unique resources available nowhere else. I mean, no matter how large the lake is, the littoral zone is the shallow water, and there are resources only there. So what limits the processes in the lake is actually the littoral zone. And I will show this. So hence, littoral zone resources can influence ecosystem processes in small and large deep lake as well. Okay, now I'm showing you two of the fish in Lake Kinneret. On the left side is the sardine, so to call it's not a true sardine, it's the bleak. Mirrorgrex, those of you who don't know, Terra Sanctum, it's an endemic fish, the Mirrorgrex of the Holy Land. And on the right side is one of the tilapias of the Homisaurus. And what we see, the hypothesis is that littoral zone provides breeding and nursery habitats for the fish, and therefore it's important. Fish breeding success is directly influenced by the availability of littoral resources. And here, the resources are rocky or stones where the bleak is spawning, or plants, vegetation, where the tilapia are building their nests. And in Lake Kinneret, there is another limiting factor, that the availability of rocky substrate and vegetation is influenced by water level fluctuation. Lake Kinneret always fluctuated 1.5 to 2 meters in the past, and now 4 meters and even more due to climate change and for the fact that we are pumping the water out or diverting the water from the lake. So this is the bleak, this is the tilapia, and no one knew at that time where the bleak, the most important, numerically the most important fish, and there is industry fishing the bleak, the sporting, I don't know how to say it in English, or that we eat, הסרדינים האלה, בקופסה, they come from Lake Kinneret. But no one knew where they breed. So what we did, we transplanted blocks, translate perpendicular to the shore, all the way into the lake, and quickly we found that the eggs on the rocks. The eggs are attached to the rock, they don't move by the waves, and if they are not attached, they are lost. They are attacked by fungi and they rot. Okay. We also found something that was a big surprise to us, that within a week to 10 days, they are covered by algae. We call this epiliton. They are sitting on the stones. And once they are covered, the stones are covered with algae, the eggs cannot attach and they are all lost. Okay, and here I show you a figure that shows on the y-axis is the number of eggs per 100 centimeters square of a rock area, and the green line is the algae, chlorophyll, also per 100 square centimeter, and in blue or bluish is the intact eggs, the live eggs, and in purple the dead eggs, and you see a clear correlation. The first of all, they breed between 7 centimeters to 25. And the literal goes to 2 meters, 3 meters, 4 and 5 meters. They are not there because it's all covered with algae. And once there is a rise of the water level, it covers a new belt of stones, another belt of stones, so they have an opportunity to lay the eggs. Now I'll show you the correlation between the change in the water level and fish population size. In 1991, many of you remember the winter we had in 1991, Lake Kinneret rise was 4 meters per season. And here in blue is the rocks that were covered by water. All the rocks, the shores were all covered, and there were plenty of rocks for the fish to spawn. And this is the result in fish number, hydroacoustic measurement. This was done by Ostrovsky and Moorline from the Lake Kinneret laboratory. And you see the clear correlation between the rise of the water level, meaning increase in substrate, spawning substrate, and increase in fish population. And this is extremely important insight to understand this relationship when we play with Lake Kinneret as we do sometimes. And it really confirmed our hypothesis, the importance of littoral resources. Now, I published a paper about it. Can littoral resources influence ecosystem processes in large deep lake? But being a young scientist, I didn't pay much attention where I published it. And this was a paper of a conference. The knowledge, but it was neglected. And only now people start to realize, yes, in the 90s, someone told us that the littoral resources are extremely important. Okay. And ponds, rain pools. The rain pools, I admit, I like these ponds. They're easy to access, they're easy to sample, to see the biodiversity, and here are sitting people who work with organisms in the ponds. And for 40 years, I was arguing to save whatever is there because they were on the verge of extinction, at least in the central coastal plain. And here you see a pond. Maybe you can turn the light. Oh, you see well? Okay. Here you see the pond filling. Those of you who are not experienced, they are dry. They have to be dry part of the year, and they fill up in winter and have water, contain water. Okay, this is wonderful. So yeah, okay. Now I'm showing you this picture because you see the students are really interested, and they saw a tree frog, Ila savigny, that had very strange coloration, so they were attracted. And by the way, the students here of mine can tell you one of the ways they picked up my students is when I want to do pieces with you. I invited them to one of our field trips with the team, and I was waiting to hear that they say, "Oh, it's wonderful! It's something." So they have been really expressing that they are interested in it because sometimes we work in polluted water, not in ponds. Okay. What made the revolution is that we started to construct rain pools, and we saw that it works. And now we're all head of municipalities really fight for money to construct ponds in their jurisdiction because it's very attractive to the public. As I mentioned, it's accessible, and it becomes material for school. And here you see some of the interest that the public has. On the right corner with blue, some of you may recognize this is the mayor of Tel Aviv. For our listeners abroad, this is the most important, or maybe most important mayor, and the strongest among the Hulda'i, and my student Liab is explaining to him how he restored the pond, and his final words, yes, I hope the public will not destroy it. And on the bottom you see a community that wanted to have a pond. Liab and myself helped them to build the pond, and this is the celebration of the pond and the first sampling to show everyone what's in there. Okay, and you don't believe that people think it's important. This is what the city of Herzliya did, inviting the public to a field trip to get to know the new city Zazen rain pool restored in the city park. A big rain pool, which was doomed if I personally didn't get involved in it. But we have some example of failure, but this is before the revolution. This is a rain pool, half a kilometer from Tel Aviv University in Ramat Aviv. I taught a course for 6 years of rain pool, and we used to go. Half of the course was field trip, and half was in class. And we used to go to this pond, sample, measure oxygen, temperature, salinity, and of course the biology. And one day I come and I see the tractor is working, and then you see it paving the road, and it ended up to be Highway 20 that we all know. Now, what I figured, and also I think the committee realized is important thing that in the academia, people also devote time to public issues. By the way, I assimilated this from Professor Hessler. He told that we the students, owe all what we have and what we get to the public. And Ramat Zahavi, by the way, was the same. So, voluntary support governmental and non-governmental organization in the protection of nature, particularly aquatic habitats, voluntary standing in court, and I will show you an example, in court and out of court dispute to remove threats from nature habitats, voluntary helping municipalities and citizens to rehabilitate aquatic habitats and construct ones, and lecture and carrying out field trips to aquatic habitats for the public of all ages, including in the Weizmann Institute in Davidson, that every year I give 2 or 3 lectures there and a field trip. Okay, and I'll give you 2 examples. These examples are success. I didn't have time to show you the one that I failed. I woke up one morning. Those of you who don't know about it will be shocked. This is what I found. The whole stream bed is covered with concrete. And the idea is this is an intermittent stream, meaning it's wet flowing in winter and it's dry in summer. But the poor intermittent stream doesn't have water in summer. So let's help him by covering it with concrete, and you will have permanent stream the year round, perennial stream. 10 million shekels were invested in this crazy catastrophe. Okay, I was furious, as you can imagine, and excuse me for the expression, and I raised hell. I really raised hell, and I wrote a letter in transliteration, the concrete stream Rabbah, an Israeli environmental catastrophe, and I brought it to all drainage authorities in Israel, to the Minister of Environment, that by the way was responsible for this catastrophe, and to other organizations, and called them for a meeting. They didn't know what to do, and once they realized what happened, and I contacted the Minister of Environment at that time, okay, and to save her face, I'm not going to tell you more. Now, finally, it worked. I want to show you this. July 5th, 2017, the trucks and the bulldozer are there. They're removing all the concrete from the stream bed, and it cost only 5 million. Half the price. Okay.
Yes.
But for us, biologists, ecologists, environmentalists, the ecological crime and the shame were obliterated. Now, the last issue that case that I show you is Lake Kinneret, and the issue is vegetation. In recent years, due to climate change, we have more frequent drought years, and the exposed shore quickly were covered with vegetation. Until the 90s, the upper picture, it was Phragmites, the reed, and later on, where we have continuous or recurrent years of drought years, the tamarinds, ashen, developed. So this caused the public to complain for a nuisance of limited access to the beach, blocking the view, and mosquitoes. Not all of this is true, but this is what they argue. We, the ecologists, argued that the vegetation plays a major role in the reproduction success. Excuse me. And here you see one example of the tilapia aurea. This is not the best picture, bear with me. Okay. And you see the nest and the density because there was a vegetation protecting the area. And on the bottom, you see another nest among the vegetation. And also the young ones, the fry, they use the vegetation as a shelter and a feeding site. The Water Authority was sued, blamed for negligence for not removing the vegetation. They took the authority to court. 2 years trial. And I was at that time, it was for 15 years, the consultant of the head of the Water Authority from the time of Netzibutaman to today. And you will see what was the court ruling. The vegetation will not be removed. And the great satisfaction for me was what convinced the judge. I raised the issue of precautionary principle, עיקרון הזהירות המונעת. If you have issues that differ, and one is endangering for a catastrophe, the other one less, you pick up the one that you expect less damage. And he accepted it. And we won, and the authority was saved. Now, this is the last one. And I turn your attention to evolutionists, and we have here are known. People say, okay, you work on rain pools. What can you find? Ask Freedom, what can you find in rain pools? No one. She's doing her career from what she finds there. Nevertheless, life is full of surprises, and biology gave us the best. I'll try to convince you. Okay, with my master student, Gil, that some of you remember, we worked on some larvae that we found sitting on the toads and frogs. And in the Weird magazine, they wrote, these grisly eggs have been documented by Gil and Avital Gazit from Tel Aviv University, Israel. Gazit discovered the beetle's behavior 4 years ago when he found several larvae attached frogs in the wild. Now he and Vision have worked out its strategy. It's unbelievable what we found. Okay, so on the right side you see the beetle, beautiful beetle, a predator, and on the left of the beetle you see the larva. Now you can also see that it has a sharp mandibles, but larva of this size is the food of frogs and toads, nothing different from others. And you see that the toad is trying to swallow, but he's not lucky. And what happens is they move out of his mouth, and even we have an example that the larva was swallowed and stayed 2 hours in the stomach. The frogs regurgitated the larva and immediately jumped on the back and sucked the frog dead. So in the science article from National Geographic, they wrote absurd creature of the week they found. And this toad isn't eating a bug, the bug is eating it. In the case of the Thomas, the name of the beetle, prey becomes predator. Now, this phenomenon is discussed and shown in the videos of the BBC still, and you can see it there with the link. And I want to show you, and this is the last slide before I say thank you. and I hope it worked. Now it's very, very fast. This is the toad. This is the larva. Some of you may see that the larva is moving the antenna, actually telling the toad, and here, come over. I hope you can see. It's very, very fast. Oh. Yeah, it was very fast. Now you think that the larva is doomed. No way. Wait and see. Now the frog is trying to get rid of it. Unable. And now the larva is changing position to the venter, to the bag, and the frog, the toad in this case, is doomed. This was really something unbelievable, and it became one of the leading examples of what we call role reversal. Predator-prey role reversal. The prey becomes the predator. This is what evolution is doing. Now, guys, I'm not resting. I'm still active. Recently discovered with Dr. Eldad Ron, my former student. We worked together. We discovered an unbelievable rain pool. It's a freshwater rain pool floating on a salt pool. And it's unbelievable. And we will be telling this in the coming conference in July of the Ecological and Environmental Science Conference to all of you. So thank you for attending.
If you're done, there's some time for question or
Just to honor the date, the name of the girl was Nika Fowler, not Fowler, the flag state.
This is what they told me. Thank you. I will correct it, and I think we deserve to put something on the zoology conference or meeting. Yes, please.
Thank you very much. In the case of the beetle larva being swallowed, why doesn't it die? Like, what about its biology or exoskeleton prevents it from meeting the same fate as other larvae?
Once the evolution went, to escape from predators, there are many ways. You can be too small for a lion to get after you. You can be too large for an animal to get after you. And in this case, it said, I'm not running away, I'm attacking. And through the evolution, apparently they have some protective cover that the juices of the stomach didn't kill. Okay, the frog doesn't have this to break it. Okay, if I have a minute, I'm going to tell you the story how Professor Hessler derived the idea of olfactory imprinting. What he tells us, he was born in Switzerland, and he took his family to see a fall, large fall that he as a boy was going, and it was in a curve, so you don't see the fall, you don't even hear it, but he smelled it. And then he was working on salmon. At that time he said, if I can smell it, why couldn't the salmon smell? And apparently they can smell few molecules in Lake Kinneret to know where they come from. And this is what leads them to the birth of the place of birth in the streams.
Okay. Just thanks again.
Good time and then the bell is out. Also,